So next one is design of isolated rectangular footing. So a rectangular footing, axle column size is given. Okay, then a load is given, then safe bearing capacity is given, then FCK FY values is given. So we know that the foundation of footing supports the column. So based on this column and the load details, we are going to design the footing. Okay, then write the given data. Okay, write the given day. First step, calculation of load. Okay, how to calculate the total load. So total load is how to calculate the load is the sum of column and the self weight of the footing. So WC plus WF. The load of the column is given as 1150. Footing is we assumed as 10% of this 10% of this self weight of the self weight of the footing is the 10% of the load of the column. Then add these two values gives the total load. Okay. Then calculation area of footing. So area of footing, how to calculate load divided by safe bearing capacity gives the area of footing. We want to know the size of the footing. So first we are going to take the size of the column. Size of the columns ratio, that is 300 by 600, that is 1 by 2. So we are going to assume that this size of the column ratio is same as that of the size of the footing ratio. Okay, that is the ratios are same. So 1:2, then y equal to 2x. So we know that area is equal to length into breadth. Assume the length as x and y as width, then x into y. Then provide the area 6.33. We already calculated in this step. Then x into y means substitute the value of x as x and y as 2x. Then we get the x and y value. Okay. Then so the size of the footing is 1.8 meter by 3.6 meter. Then next step is calculation of factored soil. Okay, calculation of factored soil. Factored means converted with 1.5 factor into WC divided by area. So this is the equation for calculation of factored soil pressure. Okay, factored soil pressure. We know that the footing is directly directly contact with the soil. So the soil have some pressure towards the footing. So we are going to calculate the calculation of factored soil pressure. It have an equation QU equal to 1.5 into WC divided by area and substitute the values. Okay, after calculating that, going to next step, step number 4, calculation of depth of footing by bending moment. So we want to calculate the depth of footing. So we are going to design the depth of footing, but before that we are going to calculate the bending moment. So to resist the bending moment, we want to design the depth. Okay, so here is the longer direction and shorter direction. So I given an equation for easy calculation. Okay, QU means that pressure, B1 means the width in the shorter span, width of the less footing in the shorter. B2 means width of the footing in the longer span. BC1 is width of the footing of width of the column in shorter span. Okay, then this is the bending moment in longer span. If bending moment in shorter span, small changes, B1 changes to B2 and BC1 2 changes to BC1. So and compare these two moment values and take the longer one, that is the maximum bending moment. Okay, after calculating, we are going to calculate the depth. Okay, calculation of moment of resistance in longer dimension. Mu is assume the value as this one, and by substituting all the values we get the value for D, that is depth. Okay, but in case of footing we take the twice the depth, and after twice the depth we are going to calculate the overall depth. Okay, then after that we are going to set footing by one way. We also provide this equation for easy calculation. Okay, shear force in longer direction and shear force in shorter direction. Substitute the values. Then the shear force is maximum. Compare the values in maximum in the shorter direction. After that you want to calculate the nominal shear stress, that is tau V, VU divided by area. Then take the maximum value of the shear. that is what 392.91. Substitute the values and areas you want to substitute. After that, calculate the shear strength of concrete, PT percentage of steel reinforcement you want to assume as this value, that is 0.2%. And then tau c we already calculate. By this we want to calculate tau c by using the code. This equation we already learned in all the design. Okay, tau c. Then compare this tau c and tau v. Then check the footing for one-way slab we already checked. Then two-way slab shear stress force at critical section. So we know that this is the portion of column and this is the footing. So this between these two portion there is a critical section. Okay, two-way shear due to for two-way shear. Okay, so we are going to assume that is total length on this side is 3.6 and D means D means the 680 mm. Then so D by 2 value you want to calculate and add this 0.6 with D by 2 here 0.3 plus D by 2 this gives 1.28 and 0.98. Okay, so calculate this one. Then you want to calculate the nominal shear stress by two-way shear. Same equation, VU divided by B0D. B0D you want to calculate, that is the perimeter of that critical section, that is shaded area. Then shaded area. Then tau v you want to calculate by this equation. Then shear strength of concrete for two-way equation is given. Assume the value of KS1. Then compare tau c with tau v for two-way shear. Okay, after that we going to calculate the area of steel by using this equation. AST, then D is 16 mm, then spacing, then shortest span AST, then AST minimum 0.12% into BD. Then you want to compare all the values and provide this value and draw this figure. Okay.